Thank you, President Yasmin. Fellow Rotarians and guests, it is my pleasure to introduce a gentleman who has given 42 years up to this point of what I consider sterling services when I look at his short profile that he sent me, and who has extensive expertise in the area of water supply development and distribution and water resource management. He started out at the Yallas pipeline project, a project that many of us can remember hearing a lot about in the days when it was really on everybody's lips. And he joined the oh geez, somebody had to do that. He joined the Water Resource Authority at the level of Deputy Managing Director in 2016. And in 2019, he became the Managing Director, and he's directly responsible for leading the strategic aspects and implementing the plans and programs to support the corporate policy of the Water Resource Authority. And with his team, they are responsible for the monitoring, management, and abstraction allocation of water resources. Peter is also the UNESCO hydrological advisor for Jamaica. He's collaborated with UNESCO on research studies relating to the challenges facing women farmers in Jamaica, and that is something that we really need to hear more of. And of course, he has represented UNESCO at international fora on the same issue. He also is at the head of the Region 4, which is the North America, Latin American Regional Hydrological Advisor. He starts with coordinating the initiatives that are relevant to the region's project. Progress. His qualifications are extensive, I can tell you that. He has impressive graduate and professional education from UTech, UWI, and various other places across the world. And so, Mr. Peter Clarke, it is our pleasure to hear you talk to us about sustainable and resilient water resource management. Although we say for Jamaica, I suspect that it would be useful for those who have joined us from the Caribbean. So over to you, Peter.
Yes, good evening, Rotarians of Manor Park, and thank you for the invitation. I actually appreciate the fact that Rotary International and Rotary Worldwide recognizes the importance and sets aside the month of March, usually for environmental matters.
I'm not from Manor Park.
Ilian, can you just mute your mic for us, please? Thanks. Okay.
Yeah, so I'm very, very glad to be here and to share with you. If I may share my screen, I'm sending the request now to share my screen. So if you could allow me to share a screen, then Richard, I guess you're the tech man.
It should be, but I allowed it.
All right, let me try again.
Nothing yet.
Yeah. I can now share.
Okay.
What I want to share again. I want to share this. Okay. So you should be seeing it now.
Yeah.
Okay. So in terms of water management in Jamaica, there are a lot of us who are actually involved. And it goes across the board, both the government and the public sector and other parts of the private sector. So clearly the Ministry of the Economic Growth, I forget that the name has changed to the Ministry of Economic Growth and Industrial Development, Infrastructure Development, and others. So it is our responsibility to strategize, plan, and develop, and for our partners to facilitate, evaluate, and assist us with mitigation. And so all of this is carried out under the framework of the Water Resources Act of 1995. So before 1995, there were not any real strong laws that were managing water resources in Jamaica. The Water Resources Act mandates somebody, in this case the Water Resources Authority, to regulate, allocate, conserve, and manage water. So as an institution, we do licensing and regulation. So if you want to drill a well, you have to get a permit to drill a well, any well. If you want to abstract water from that well, you have to get a license to abstract it, and we will do the calculations to how much you can abstract and so on, and large abstractions for large domestic purposes and so on, and industrial purposes from rivers, streams, and springs, like bottled water thing. If you have a stream or a spring on your property for your own personal use, you do not need a license. You are free to abstract that water. And of course, we're concerned with water resource engineering, environmental quality, planning and investigation. And a big thing for us over on the right there is resource monitoring and data collection, monitoring the rivers, both and water, groundwater for quality and quantity. So we're concerned with raw water control. We calculate how much an aquifer can yield. We assess well drilling operations and so on. And a big output from our operations is right there at the top, the National Water Resources Master Plan. And we will see that again later. And we will also see the mantra there in blue: reserve, reclaim, redirect, reuse, reduce, and restrict. Everybody knows about the 3 R's, but we operate off a 6R principle. So we do the surface water monitoring, we do the groundwater monitoring, we do the mapping, we do the data collection, and we keep an inventory. And our inventory is free share. So we do not charge for the data that we've been collecting over the last for more than 50 years in Jamaica. We do not charge for it, and it is available to all our researchers, academics, developers, everybody. And you can see a lot of what we're concerned with, and we'll get more details on those. Our big management challenge for water resources in Jamaica right now is the matter that some of our water, our groundwater, is being contaminated by seawater. We call it saline upconing. That we have aquifer depletion, that we have abstraction interference where one well could be interfering with another. So overall, the groundwater exploitation, there are issues with that. And for surface water exploitation, it's largely downstream economy losses because you divert the water away from somebody and they would want to be using it. And downstream ecology losses, you divert the water away and the river dies, the river dries up downstream or whatever. So these are things that we have to be concerned about, and these are the things that these are the challenges that we certainly try to mitigate against, and I think we've done a reasonably good job so far. We're there for development decisions. So when you apply for a development, you send your submission in, the submission is going to go to NEPA for the approval from NEPA. Well, when it comes to the water issues and the water resource issues, NEPA is going to send it, that's your same application, to us for our comments. And they will respect our comments, and they will then pass that back on to the developer, whether to fix something or to not get the development, or for the development to be approved. We're there for mining decisions in the whole matter of the cockpit country and the delimitation of the cockpit country, and putting where the boundaries are supposed to be or is supposed to be. We were an integral part of that discussion in setting the final boundaries for the cockpit country. Simply because the cockpit country in and of itself provides 40% of Jamaica's fresh water. So a lot of our rivers emanate out of the cockpit country. Rio Bueno, Great River, Martha Bray, Cabarita River, Black River, all of these rivers originate in the cockpit country. So speaking of that, I just brought this in so that for those of you who might have an idea of what the map of Jamaica looks like. I see somebody's here from Bahamas, for instance. So this cockpit country is now a protected area. All right. We also, for instance, we are also integrally determining where cemeteries can be sited or where they cannot be sited. So we've produced maps for that, which we've passed on to all the municipal corporations, and they use these in their planning and in their advancing of the development of their own municipality, their own parish. Jamaica is trying very hard now to join the United Nations and UNESCO with a preserved area, a biosphere where man and nature lives harmoniously. And the proposal, the submission that is being made is for along the White River corridor for it to be so designated. It's a faraway advanced, and and the submissions will be made, I think, later this year for that to happen. It will be a big thing for us if we finally have a recognized biosphere here in Jamaica. I spoke about the fact that when we take in water from rivers and so on, that downstream especially, there can be economic and ecological losses. So we recognize that whenever you're doing any abstractions, you have to maintain an environmental flow, providing a quantity and quality of stream flow to maintain the ecosystem and livelihoods that are dependent on that stream. So we call that the environmental flow or the environmental demand. It's very important. Wildlife is important and habitat protection is important. There are public health considerations because downstream a lot of people may be using the water for their own domestic purposes, and you take that from them, then basically you put them in a position where they don't have access to water and other reasons. So big challenges to environmental flow are climate change. Our rivers, the capacity of our rivers can change, over allocation or over abstraction or illegal abstraction that's not there, and also pollution. When you speak of the pollution now, why we have the situation with the rivers being polluted? The thing is, rivers very quickly heal themselves. So you hear, for instance, that Rio Cobra is polluted by a spill from Rio Tinto or the bauxite company. And yes, it does have an impact. But the fact is that within a week or two after that discharge of whatever effluent would have caused the situation, within a week of that passing, the river is back to its normal self. While your groundwater, when that is polluted, it is polluted for more than life. And when I say life, I mean we have a average lifetime of 70 years according to the good book. All right, but the fact of the matter is that we have places that have been polluted and the pollution point stopped more than 70 years ago, but the pollution still exists. So most of our pollution in our groundwater, you can see the browns, that's nitrate from absorption, pits and so on. You can see the seawater that would make the groundwater get salty. You can see the caustic soda from bauxite and dunder waste from sugar industry. Those have been essentially our largest pollutants of our groundwater across Jamaica. You can see where it's concentrated. And interestingly enough, if you know the parishes of Jamaica, right in that yellow along the bottom there is very significant because a lot of our urban centers are located in that bottom yellow area. So when we're monitoring, we monitor the groundwater for quite a few parameters. We monitor for chlorides, which will show us, that the salt is in your sodium chloride. We monitor for nitrates, and all of these things. And then we put it all together and decide what can we do about it. So when we do for instance, with regards to let's put it this way, we have determined aquifer protection zones. The objective is to allow for development to take place by mitigating against negative impacts. All right, so we've designated a large aquifer protection zone, and you shall see the map shortly. Since 2016, we've more than supported it. It's not a no-build zone, it's a care-build zone. So we'll have to spend a little time talking about it, especially because a lot of the future plans that the government has in terms of development in the Bernard Lodge area and so on, some of it falls within the aquifer protection zone. So that is very important. So we were very involved in the Bernard Lodge master plan. All right. So this is a map, a Google map really, showing you that red line is showing the outline of the aquifer protection zone, and all of that silvery housing looking thing to the right is Greater Portmore. If you look to if you can see my cursor, right up here is Soapberry, which is the main sewage treatment plant that takes almost all of Kingston's sewer water and treats it before depositing it in the Rio Cobra, which is right here, which then goes out into Greenwich Bay. So I will see more about that plant shortly. So the aquifer protection zone it's not covering an entire aquifer. It's covering a large part of an aquifer. Basically, we have two types of aquifers in Jamaica. We have what you call the alluvium or the sandy aquifer, which makes sense to you, that water soaks down through the sand and goes down into the ground and stays there. And then we have the limestone aquifers, and we have a lot of limestone aquifers. So this aquifer protection zone is actually in alluvium aquifer. The limestone aquifers, we'll speak a little bit about that as well, because that is very critical. As a matter of fact, our cockpit country is largely limestone aquifer. And we find it is, as much as it is a more solid consistency compared to a sandy, loamy area, it serves a completely important, gives complete important service to us here in Jamaica. So these are just, for instance, the same aquifer protection zone. The red dots are just where wells are inside that zone. So we have to be careful about, maintaining these wells. They're active. Yeah, your concerns are infiltration in a zone like this can be reduced. That recharge to your aquifer can be reduced. That runoff in that area with all of the houses that you've built and the hardscape that you've put in, roads and houses and roofs and all of these things and car parks and whatnot, can increase runoff. That abstraction can increase because you have so much more demand. That water supply can then be unsupported, and that overall water quality can be degraded. So those are your impacts, and mitigation is just to try to not make that happen. So it's a total area of 30 square kilometers, all right, of which roughly 4.9 square kilometers is already in housing. And the mitigation, especially with what you're seeing there now, because what you're seeing in the colors is the proposed Greater Bernard Lodge development that's coming. So if you look at that, you can see that the blue is housing, the green is agriculture, and the dark blue it will be industrial, commercial designated areas. So the important thing in there is to capture a lot of that runoff that's going to happen when you have rainfall. So detention ponds will be a major feature, or should be a major feature of the area. And detention and retention ponds, a lot of us who have traveled to places like Florida, South Florida especially, would see these communities and developments and schemes with ponds and lakes inside there. They're not accident. They are specifically engineered and built as a part of the overall development to capture stormwater and rainwater so that the water can slowly soak into the ground and recharge their aquifers. And this is the concept that we have pushed to happen, for instance, with the Greater Bernard Lodge, and I really hope that it will come to fruition so that we can help to sustain this aquifer, this very important aquifer that we take water from for parts of St. Catherine and all of that. So nearby, you have now the limestone aquifer. And that limestone aquifer also is serving that serving the southeast St. Catherine area, so the whole of Portmore and so on. So wells are in the limestone aquifer. But the fact is that if you want to take more water out of the ground, you have to put water into the ground. And so we have developed, and it has been constructed at a cost of 1.07 billion Jamaican dollars back in 2014. We have developed an artificial groundwater recharge system. So you may recall that there is a dam as you go into the Boardwalk Gorge. That dam was built by the National Irrigation Commission for irrigation purposes. And you see a canal system. And on Sunday evening, when you pass out Spanish Town area, you see the kids swimming in canals, having a Sunday evening swim, for instance. And those canals carry water to farmers. Now, farmers don't use water 24 hours a day. Sometimes they don't use water 7 days a week. Sometimes they don't use water for a month. If it's raining, because you have to pay for this water. So if it's raining, why buy the water if it's raining? So what it means is that this water in the canal is generally going back to the sea. So the canal, the whole dam and canal structure becomes a very inexpensive alternative measure of moving the parts of the workover back to the sea rather than leaving it in the river channel to run. So rather than have it going to waste, we take that water and we have built a system and inject that water into the aquifer. And it's been happening since 2014. at a rate of between 5 and 8 million gallons per day of raw water going back to the aquifer. So it conserves wells. It allows us to have a safe yield of the abstraction from the aquifer. Now, the takeaway is that even with all of that, in the whole of that South St. Catherine area, the water balance is pretty much even. In other words, what you're taking and what is replenishing is just about even. So if you take any more, you are now going to be taking more than what is coming in, and it means that your aquifer will deplete. As a result of that, there is a moratorium on doing any new wells in the whole of South St. Catherine area. So no new wells have been drilled in that area for the last, I would say, 15 years. What it means is that if you have a well there, it's fine. And if you have a well and the well goes bad, like it gets clogged up or whatever, you're allowed to drill a new well to replace that well. But no new person can come into that area, no matter who you are. And I've had applications from members of parliament who have property in St. Catherine and would like to develop. I have applications from people with very big names in this country and small names and all kinds of names. And the answer has been a flat no, sorry. There are no new wells in this area. So that is one of the big things. So no increased abstraction is taking place. And so we've been able to basically lessen the water abstraction. In terms of water quality, and coming out of what is to happen with Greater Bernard Lodge, no final effluent is to be disposed of on site anywhere inside there. That is one of the big things that's coming out of that. What else? Regularization of the current informal settlers, because a lot of the pollution that can take place with your groundwater can come from informal settlements. The restricted use of sanctioned hazardous substances, and there must be centralized sewage treatment. So those are all parts of the parameters that we have put inside of the whole thing to say, listen, don't let this thing happen. Let us protect it. We're using advanced atomic technology, isotope hydrology, to determine the state of the aquifer, both in terms of the quality and in terms of the remaining volume. And that has allowed us to have improved monitoring and improved assessment. So that is fantastic. And we're doing that with the assistance of the IAEA, the International Atomic Energy Agency based in Austria. I've had a number of my staff who've gone to Austria. I've never been there myself, but a number have gone there for training in this thing. And staff also from some parts of Water Commission and National Irrigation Commission and so on. We've joined it up. So we have not, it's not just for ourselves alone. And so the fact is that we have tried to create a joined up process to help us to manage, and especially in this case, to assess what the situation is. So the takeaway, as I've said now, enforce restrictions, new technology, improve monitoring, risk reduction, and it all leads to quicker response to issues that can crop up in this area. And we want to commend all our stakeholders who would have joined us in this, so that we can make it so that it has been as successful as it has been so far. These are just the risks. I'm just running over again, and you saw them on the mitigation. Again, the detention points, the artificial recharge, and so on. So these are all the mitigation and the enforced restrictions, like the moratorium on new whatever on any wells and so on. So the fact is that with clear build methodology, we can make development and the environment coexist. Okay? So yes, we recognize that there are water-related impacts. Floods, droughts, changing weather due to climate change, for instance, increased evaporation. This is what we mean by increased water loss due to warmer air temperatures. That is just a long way of saying increased evaporation. Sea level rise and saltwater intrusion. Again, most of these are responses to climate change, not welcome responses. And so we always have to be planning how to mitigate them. And of course, the continued increase in demand for drinking water, agricultural water, industrial water, and so on. One of the big things that helps us as a country to make these decisions and to make plans is the publication that the Water Resources Authority does called the Water Resources Master Plan. And what we do is we assess the water demand and we assess water availability. And what we've done in the last iteration of the plan is to incorporate climate change parameters and to present that in a forecast to an event horizon of 2080. And you're going to see what we're looking at and what we face as we proceed between now, 2020, we're almost at 2030, in another 4 years, we're at 2030. So you see what we are progressing to in the next 50 years. On the bottom of the chart, on the bottom of the screen, what you're seeing is just, for instance, one of the measures that is a part of the whole overall mitigation, which is we're trying to build resilience in this country. So, for instance, as you know, St. Elizabeth is the breadbasket of Jamaica. All right, Manchester is the breadbasket of women farmers in Jamaica. So a lot of the irrigation that takes place is using water that is really pristine. It's using water from wells, for instance, which all you have to do is put a little chlorine in it, just in case it could get contaminated before delivery. And that is what is being used for irrigation. Now, that is a waste of good water. So we can reserve that water for better use, which is a domestic, very important sanitation use, if we now use a raw water that is not of such quality, as such a high quality as that pristine groundwater. And so we're looking, and the project has started now for us to take water from the Black River, which is a raw untreated water, and use that for irrigation. So you'll be hearing about the Black River, the Pedro Plains project sometime soon. And in that now, that will be basically irrigating the farming belt of South St. Elizabeth. And then that farming belt that has been using a lot of fresh water now, that fresh water will be reserved and allowed now to be used for domestic needs. How do we plan this? How do we do this whole master plan and everything? Well, you have to have a system. So we've divided Jamaica into 10 hydrological basins. Now, these are not parish boundaries. These are hydrological basins, which are basically not delineated, but designated through any major river system that's there. All right, so you can see, and then like in the Blue Mountain North, there are so many, we just say Blue Mountain North, and then Blue Mountain South, you have quite a few rivers again, you don't have any one main river, and so we just say Blue Mountain South. And Kingston has the Hope River, and incidentally, it has the Fresh River. So what do? We monitor. This is very important. We're a data-driven entity. All right, we consider ourselves, I was an engineer for 30 odd years working for Clarke Engineering, which was a government company that started building the Yalas pipeline, and also Rural Water Supply Limited. But for the last 10 years, I've been a scientist. And it's as much fun. So I'm not out in the field as much, but I'm still making, my team and we're still making a contribution, a very meaningful contribution. So one of the big things is monitoring. So we have these monitoring stations all over. And so we're monitoring all of these rivers and streams. And you may pass these stations sometimes. They look something like these. There are different types. So the latest kind that we're using is this one that you can see right here. I don't know if you can see my cursor, but this one, second from the left at the bottom. Now this one is non-contact. So you have a radar that's here, and it's picking, the radar is reading down to the river level, and it's picking up the flow of the river. And then from that, we can do the calculations to get the volume of flow of the river that is passing along on a daily basis. These other ones are contact systems, like the three on the top are all contact systems that are in contact with the river. Now, if the river is pushing a lot of sediment, then it is going to get sediment up into this tube, let's call it that. And that can give you false readings. And so the non-contact method is the way to go. And the thing with the non-contact method is that it now allows for us to get the signals, the information coming in real time. And then we can use that information for a number of things. We can use it for more flood forecasting. We can use it for early warnings. We can use, and it is just how we are advancing using the technology. So we're very much excited whenever there is a storm or anything like that, because it means that our rivers are going to be presented as high flows. And so the teams are always prepared to go out in storms and to do measurements and so on. This data, as I say, it's important. It's important to us, but it's important to, as it was said in the introduction, I'm a part of a global fraternity, and we're pulling data from each other in the Caribbean as well to come up with, for instance, forecasts on drought and so on. And so data determines decision. When we speak, we're speaking from the position of numbers. So it is using the numbers that tell us what we know, and using those numbers, what we can say. So that is the whole point of it. And then we can analyze, we can make statements from it. So we can say, for instance, that this is the Rio Grande River at Alligator Church in Portland. We can say that it's roughly 35.3 million gallons per day flows through the river. And then in January 2024, 134.6 million gallons per day was passing the river. Same time in January in 2023, it was 37.2. So that tells you already that 2023 was a drier year. And so on. And February 2024 showed a 50.5. So you can see that we can use these things to make correlations. And also, the fact is that our only form of water input in Jamaica is rainfall. We don't have snow, we don't have snow melt, we don't have glacier and glacier melt and so on. So rainfall is absolutely critical for us. So you will see that we work also closely with the Met Office, and that will come up. So one of the things that we do, so what do we know and what can we say? So one of the things that we can say is we produce bulletins, and these bulletins are used by technical people mainly. I mean, the average person in the street is not necessarily interested in what's happening in the bulletins, but we do produce the bulletins, and then the take up is quite good with that, and people are using that in their own plans. Working with the Met Office now, we can do runoff estimation analysis. We can do groundwater recharge analysis. We can do water balance studies of water catchments. We can do flood analysis to help to design hydraulic structures like bridges, dams, and so on. Real-time flood forecasting, and of course, low flow studies, so that we can help to speak on when is the onset of drought. And if we have 4 different types of drought, all right? So you have the meteorological drought, the hydrological drought, the agricultural drought, and the economic drought. And all that means is that each one is a more severe advancement into a stage of drought. So the meteorological drought is not raining, all right? So hydrological drought is not raining, and it started affecting your rivers and your groundwater especially. Agricultural drought is not raining, water resources are down, and it's affecting your farming output. And then economical drought now, your farming output is down, and you heard Richard Byes, President, Governor of the Bank of Jamaica, said the other day that agriculture was one of the driving forces that had been advancing us with GDP and moving our indices in a positive manner. So it all is tied up in a loop. In Jamaica, we have 2 dry periods. We are now in our current dry, we have a bimodal weather pattern, 2 dry periods, 2 wet periods, and we're now in our minor dry period. So December, January, February, March is a dry period for us. And then we start getting the rains in late in April into May and parts of June. Then we go into our next dry period. And then we're going to a wet period again in September, October, November. All right. So you can see the highs and the lows on the right, 2 wet and 2 dry. I said that we work with our regional partners. And so we are using our forecast, our Met Office forecast, our Water Resources Authority forecast, and so on. I'm working with the Climate Studies Group out of UA and others, and there's a publication called the Precipitation Outlook for the Caribbean, and this comes out every 3 months, and it outlines essentially what it's going to look like with regards to rain and so on in our near future, and they are quite reliable. So this has been good for us. So this is one of the things that we're involved with. All of these are important. Remember, the topic on this thing is sustainable development, And you need to have as much information as you can get your hands on, or get into your mind and get into your thought process, so that you can make the proper decisions when you want to build anything, or develop. The fact is, climate change is real. It's getting hotter. All right. And the numbers you're seeing, this is Jamaica. And you can see that in all parameters, both in max, in minimum, and in average, that the temperature is going up. Now it's not a big jump up, but the fact is that with temperature, a couple of degrees is a big thing, which is why the mantra of the climate studies group and Professor Michael Taylor is 1.5 to stay alive. In other words, let's not have a greater increase than 1.5 degrees Celsius over the next 30 years, until, so that we can help to withstand the effects of climate change. But it is getting hotter. And every year is getting hotter than the year before. So 2023 was hot, 2024 was hotter, 2025 was even hotter. Records were set in 2025. Let's see what 2026 brings. And I hope that we will see the time when we are seeing dips in the temperature, consistent dips in the temperature as well. Higher temperature means more evaporation. So that is a fact of life. That is just the physics of our that's just our Earth, our Earth physics. So let's look at the Mona Reservoir, a very well-known water resource structure for Kingston. The size of it is roughly 70 acres. The wind speed, let us say the average wind speed on a summer day is 15 kilometers per hour, and the average air temperature is 80 degrees Fahrenheit. And the average humidity is 50%. That gives you an evaporation rate at the Mona Reservoir of 85,000 gallons per hour. All right. Now, this is during the 6 hours when it's really hot, 85,000 gallons per hour. And you have how much coming in? You have 500,000 gallons per hour coming in from the Hope River and the Yalas pipeline, at 85,000 gallons per hour evaporating. So that means that what you're going to say is that over the 6 hours, you've lost 17%. But because at the cooler times and during the night, water is still coming in, it means that the actual loss over the 24-hour period is 4%. Now, that's a lot of water to lose daily to evaporation. There has been in terms of trying to reduce evaporation, there's been a pilot project at the Mona Reservoir to put solar panels on the reservoir, use the sun to generate electricity to run the treatment plant that's there and the offices and so on that's there, and at the same time use the panels to shield the water from evaporation. It proved to be reasonably feasible, and I would suspect that the people that are involved with that, they are foreigners. I'd suspect that they are at the drawing board looking at a build out for that. We wait and see, and we hope that will be fruitful. But back to our climate change situation and whatnot. I mean, you may recall when Somerset Falls stopped flowing, and it was big news when it started flowing again. This is 2019. The same thing happened again in 2022. Okay? And the same thing happened again before that in 2012. So Somerset Falls has stopped flowing a number of times through the years when we've had serious drought. The other situation with climate change is sea level rise. People wonder how sea level rise is. No, the common one that most people will relate to is that the heat melts the ice, and the ice melts like the glaciers and the ice caps and so on. They melt and they run from the land into the sea, and the sea level rises. Yes, that happens. But actually, that rise is not as significant as the rise that takes place from the natural heating of water. Now, when you boil water, all right, it expands. And when you increase the temperature of water, it also expands. You don't have to boil it, and as you increase the temperature of water, it expands. Now, if the sea is sitting on the bottom of the seabed already, it can't expand down into the ground or the seabed, so it can only expand up. So that is why sea level rise happens also when you have these increased temperatures that it is projected that we're going to face. The fact that the sea is going to expand and it can't go down because it's confined by the ground layer of the seabed already, so it can't expand anywhere else but up. So that is a concern. And this is Jamaica, and we have been monitoring as well and seeing how it rises and falls. And you can see how much it rises, for instance, in a summer period compared to the rest of the time across the year. So sea level rise is real. Now remember I spoke about the fact that we do the, what you call it now? The master plan. Look at this chart now. And what this is showing you is that using an event horizon, we're looking at a very dire situation as a country with water deficit before 2100. I can't say anything more about that than the fact that this is a projection and it's a forecast, and we're using real numbers and we're putting it in models, and this is what we've come up with. It means that we have to mitigate against this. We have to plan for this and mitigate against this. Short-term response for us has been trucking in Jamaica. Another medium response is rainwater harvesting, as you may have heard. And included with that, now we're talking about detention ponds and retention ponds and so on, and the whole development approval process and collecting surface water runoff and planning up to do underground storage at large car parks and commercial centers and so on. That is very important. That has to be a part of our medium-term response. We have to recognize that when the rain falls, we can't allow it to run away. We can't allow it to the surface water to go. It has to be collected. Reforestation of our watersheds is important. Maintaining our wetlands is important. Fast-tracking current projects, that is important. One of the fast-track ones now is the Rio Cobra water supply project you see right here, which is to bring an additional 15 million gallons of water in today. The matter of fixing leaky pipes and changing out leaky pipes, all of these are important, and a lot of these are ongoing. Improved distribution and so on. The fact is that these projects, a lot of them have been conceptualized a long time ago. Some of them are recent. But what is clear is that they need to be put in place already. This is just a drawing, and you'll pass this when you go on the highway going up the North-South Highway. You'll see the construction going on for the new treatment plant at Content. On the right-hand side when you're going outside of Spanish Town, going along the North-South Highway. So that's there. Artificial groundwater recharge. I told you about that. We're increasing the bank of water on the bank of groundwater. We're using that fresh water that we're putting to push back a lot of that salt water that I showed you on that map that's coming in on the south, to push back that salt water and to get that away. And also to provide storage, because basically storing the water underground, where it won't evaporate because it's not in direct sunlight, as opposed to storing water above ground. So all of that makes it a positive. And this is just the engineering of it, but the fact is that, and I can move on, but it covers 69 acres out at Innswood. And after the water goes through the natural treatment processes, it gets injected into sinkholes that are present there, as well as abandoned wells. So that's how it works. And this is just construction pictures and so on. This is just a Google Earth of the facility, Google Earth shot of the facility. Another shot of the facility out there. This is just one of the settling beds. So there are 4 settling beds and 8 wetland beds. So it's all natural treatment. The wetland beds remove the nitrogen, the potassium, and the phosphate, basically the fertilizers out of the water, so that we can inject a reasonably clean water back into the ground, into the aquifer for future purposes. All right. I have to move fast because the time is going really. But the water sector improvement, we're looking at a number of things. We're looking at in terms of dams, we're looking at 2 dams in our very near future. One on the Rock River in Clarendon to help to sort out the whole Mapen area, and the Hermitage Dam. Now next year, the Hermitage Dam shall be 100 years old. That makes it one of the 4th oldest working dam on this planet. So we have to be very careful with it. People will ask why you don't desilt it to any great extent or whatever. It's because the silt that's down at the bottom of it is doing a job. Or we suspect that it's doing a job. And what we suspect that it's doing it is that it's creating an earth buffer underneath the water so that the dam doesn't fall over, because that is there at the bottom, so that the bottom of the dam doesn't come inwards and the top goes over on the outside. So that is there. So the plan then now is to, the first concept was they were thinking of raising the height of the dam wall. But then when you consider it's nearly it's 99 years old, you don't want to go mess with that too much. So the next thing now is to basically do a new dam wall downstream, higher down, and that will come up higher and help to create more of a reservoir, and just about double or triple the water capacity, this water holding capacity of Hermitage. So those two dams are coming. The other thing is wastewater reuse. Kingston uses 46 million gallons of water per day. That means that Kingston produces 46 million gallons of wastewater per day, which just goes to get treatment and then goes to the sea. But there are other things you can do with wastewater. There's irrigation, for instance. So we have to recognize the value of the water that is embedded in wastewater. I've already spoken about the value of water that's embedded in surface water. So when you recognize that apart from our rivers and our aquifers and so on, our groundwater, that we have other water resources. Our surface runoff is a water resource. Our wastewater is a water resource. We just need to do what is in place, what we can put in place. We just need to do what we can to harness the water that's in wastewater and harness the water that's in surface water. Interbasin transfer, for instance, you asked about what pipeline is interbasin transfer, removing water from one catchment basin to another catchment basin for their needs. And we're looking, for instance, we've given proposals to move, Rio Bueno to Kingston, just to the Spanish Town area, for instance. And there's a particular reason why I went there. I don't think I'll do the hydropower because time is of the essence, but I want to speak about this. So in our future, looking at this whole dry thing now, the situation is that we'll have to look at water, wastewater and all of this, but also somewhere in our future is desalination. Now, personally, desalination is very expensive because it takes a lot of energy to move the water through the very small membranes to remove a sodium ion and a chloride ion and to still leave a water molecule. However, so it takes energy to operate the pumps that will push it through those very fine membranes. But those of us who swim even and go to the bottom of a pool, and those of us who dive and go further out, know the effect of water pressure on our body. And that is just at a few feet. Now, at 100 meters or so deep, that's a phenomenal water pressure. And that water pressure is strong enough to push the salt water through membranes within the system and to create fresh water. And then you just use now, not the high pressure pumps like what you'd use for the desalination, but just normal pumps to pump that fresh water now to shore and to use. So this is something, for instance, that is quite attractive. It's being developed now in Norway. It is we have a great interest in it. They're doing pilots. They've been doing pilot studies in Norway and in Saudi Arabia because the Saudi Arabians can afford to foot the bill for the experiment, basically, because the prototypes have been built. But if it proves to be successful, it can be a game changer for desalination. Now we do have desalination plants in Jamaica. They're small plants, they're owned by hotels, and they use it as a backup system so that if the NWC system goes down, they have a backup supply because your guests can't turn on a pipe and hear air. That kills your hotel. They have to always have water. All right? We said that we're interested in what's happening with flooding. We have 5 types of flooding. And the other day after Melissa, one was very prominent in the news a lot, which is groundwater-induced depression flooding. That's when groundwater is now flowing up into depressions. All right. So this is your normal flooding that everybody knows when it comes to rivers. This is the Hope River here. This is the Kintyre area, and this is Hope River again. This is Wagwater River. This is groundwater depression flooding now. Now, this is not content. This is picture is from 2020, 2008. This is Monique. And these houses are still underwater. I personally took these pictures, and to this day, these houses are still underwater. This is Monique where you know, they built too close to the lake, and the groundwater rose. This happens, and so, you know, that's that part of the things that we have to study. So we're very integral in the discussions about what's happening with content and what should happen in the future with content. And we have other areas. So for instance, Newmarket is not groundwater now. Newmarket is surface water that's flowing down into a depression, and because sinkholes get blocked, it can't drain away as fast. So this is a situation. This is a Newmarket situation on the right there. This picture was the other day after Melissa. And you have other areas. So it's very important that somebody is doing these monitoring, somebody's doing the studies and so on. And we do it. We prepare floodplain maps. We declare floodwater control areas. We implement the structures to mitigate flooding impacts. We provide a floodwater control master plan, and we set up early warning systems. Our most important early warning system, so this is just copies of maps and so on, is in the Bogwalk Flatbridge area. And we are the ones who do the trigger to let the Bogwalk, to let the Flatbridge close. It's not closed because somebody is looking on the river and saying, boy, it looks like the river rising, let's close the road. It's not closed because somebody is saying, I don't like the color of the river. It's closed because we have equipment that's further out beyond the bridge. And that is telling us that based on how the rain is falling, based on how the flows are at that area, the bridge will be inundated and you need to close the gorge for the safety of the public. And there have been times when it's been raining and people want to close it, and they call us and I say, hey, yo, you don't think we should close it? I said, no. The numbers say it's not going to happen, so relax yourself. And it don't happen. So the fact is that maybe we have a lot of dependence and reliance and confidence in the science, but it's what we know about. We don't know about, we can't bake Easter bun and make cheese, but we know about what's happening with waters and rivers and so on. So this is just, and then we have a system now where the information comes in real time. So this is a screenshot just from one of our screens in our control center, and it's showing the precipitation, it's showing the stage mean height of the river at the top there. It's even showing the condition of the battery at the bottom, because the battery is there to send to maintain the system, to send the signal along. So the way forward is all policy. It's all about what the policy direction. The policy directive says try to pay attention to desalination, whatever it is. The policy decision is say don't build more houses and don't build more and cut out and reduce agriculture in a particular area. We have to respond to that, find the solutions and so on. The fact is that for us, as I said, we use the 6 R's. And these are the common things that you think about when you think about water, and stormwater and wastewater and freshwater use and balance and so on. But as we go forward, we recognize that with changing land use and climate change, it's more than water. It's water plus this, water plus that, and water plus something else. So that means that it is water plus reclaiming watersheds, water plus looking at how you do packaging and throwaways and reusing that, watershed degradation, your decisions about agriculture versus domestic and so on. The fact is that for us, the motto of the Water Resources Authority is every drop is precious. And so that's a part of all of what is happening as we try to sustain, exploit a resource in a sustainable manner. Thank you.
Thank you so much, Peter Clarke. What an informative and interesting presentation, Rotarians, ladies and gentlemen. Peter, you have time for a few questions?
Sure.
Okay, great. So I'm going to ask anyone who would like to ask a question, just raise your hand and I'll identify you and then allow you to ask your question. Peter, I'll go first.
Sure.
I really learned a lot from your presentation. One of the things I heard just this morning, actually, on the news is that the Water Commission has implemented water restrictions in the Constant Spring area, the St. Andrew,
Mm-hmm.
that part of St. Andrew.
Mm-hmm. Mm-hmm.
And I live just below that dam, the Hermitage Dam.
Mm-hmm.
And it wasn't too long ago that we were told that it was at the point of possibly overflowing because
Mm-hmm.
of the amount of rain that we get. But this morning they're saying that the water restrictions are now in place because the dam is down to 65%. Now, how does a dam that is collecting water in this area upon every day, there is some rainfall, can go from 100% to 65?
It's quite simple actually. It's quite simple actually. I don't remember your name, President.
Yasmin.
Yasmin, the situation is that the reservoir, all the reservoirs, all our reservoirs, at the end of the day, depend on rainfall. So if the water that's coming in through the river is not more than what is being taken off from the dam, or if it is less than what is being taken off from the dam, then the dam is going, its input is it's math. Input minus output equals delta storage, change in storage. So if input is greater than output, storage goes up. If input is less than storage, if input is less than output, storage goes down. And that's exactly what is happening. So because we've gone through essentially a dry period, Kingston still need, whether it's wet or dry, Kingston still wants to have 46 million gallons per day.
Ah, okay.
That don't change.
Yes.
That has not changed. And so until we move from that any dependency in that manner, or until we've created such a vast storage that when you do drop, you still know that you can serve the needs of the customers, then you won't be having the restrictions. And the Water Commission now, they have a index. So once their numbers say that it is 65%, even if they have a forecast that it's going to rain next week, they ought to be saying, we're going to restrict. All right? And it's the same thing with Mona Reservoir. That also has an index, and when that goes down, then no. People also say, why we don't desilt the Mona Reservoir, because they are remove sediment from the Mona Reservoir. So I'll tell you a little fact. The Mona Reservoir was built in the 40s. After it was constructed, for 2.5 years, it leaked, wouldn't hold any water. All right, remember, this was built now by the colonials, the English people and everybody, they built it. And it leaked for 2.5 years. They had gotten all this fancy clay mud from up in what do you call it in the past, Dovecote and Gope? I forget the name of that area. So they got all of this stuff, and it would still leaking. They had to send to England to get a particular material called gunite and remove all of the bottom, put in the expensive imported gunite in the bottom, and it stop leaking. Now, if you want to desilt it, here are the two main constraints against desilting it. One, to desilt it, you have to take it out of service. You can't desilt it full of water. You have to basically run it down to sludge. We cannot afford to run Mona down to sludge anytime in our lifetime right now. If we do that, we cannot afford to shut. And so that's the first. The second thing is that it's going to take time. It's not going to be desilted in 2 days. You're talking 2 months or thereabouts. Right? And I see a hand, Chris Nakash. I soon come to you. So it can't be desilted in 2 days. We cannot afford to be out of Mona Reservoir for 5 days in this country. Is chaos. And the third thing is that bottom, that gunite. When you are desilting it, so the gunite is there and then the mud is on top. When you now put the suction, the stuff now to remove the mud, how can you determine that you can move mud and don't move the protective layer at the bottom? You can't do it. You can't physically, you can take out a little bit. And finally, and probably most importantly, is the fact that as much as we are talking about Mona Reservoir full of mud and sun and everything, based on the calculations, because they've done the hydrographic surveys and everything of it, it is about 15% mud. It's not the 50% mud. So we're living with it.
And
Tanaka.
that is consoling to hear that it's only 15%.
Yeah, and I think I've explained the other, and then also to forego now the whole matter of the lock-offs now, we're trying to get this plant constructed double quick time out at content to bring an additional 15 million gallons in. The other thing is fixing leaks, because 5 years ago, Kingston was using 60 million gallons of water per day. We're down to 45. So by fixing the leaks and stopping 15 million gallons from leaking away, it means that we have increased our stock by 15 million gallons. So that is very important. A whole leak detection and leak fixing and mains replacement of the old rotten mains and so on. Yeah, Chris.
I heard at one point, and I don't know how true it is, but is it true that Hermitage is operating at a relatively low number, like 27 or 30% of its original design capacity because of silting?
No, it's more than that. It's more than that. In other words, what you're saying is that it is roughly 65 to 70% silt, or 70 to 75% silt. No, it's not. And they have done some amount of desilting there, but it's more of a skimming, you know. Now the situation, is that the rate of sedimentation determines the life of any reservoir. So if you can reduce the rate of sedimentation, then you can make it last longer as a storage area. So for instance, with Mona, once it's raining and the water, the Hope River starts getting muddy, they turn off the water, they divert it back into the river, it doesn't go to the reservoir. And that's what has saved us over all these years, that the sedimentation is not as high as it is. And the same thing, the Yalas pipeline, they turn it off. Now, that is a reservoir. Hermitage Dam is an actual dam. It is a structure on the river. So you can't turn off the river. So it will always, in a sense, have more silt deposits annually than the Mona Reservoir. They have done some amount of desilting up there where they have brought in trucks and so on and removed sand and everything. My problem really was that, to be serious about it, let me put it another way. I'm trying to be very careful now. When the last 2 times that they were desilting Mona Reservoir, they offered the sand for sale. Let's put it that way. And let's put it that you offer the sand for sale, and the take up, I think, would have been a lot more. A lot more people would have taken up to come there with trucks and move sand if the sand was free. And I didn't see the point of selling the sand. I don't see the point of selling the sand, but that's just me, But no, to be frank, I can't tell you the exact number, and I can find out, but it is not 70% mud or sediment.
I can see the sediment at Mona being better quality, but I would imagine that the material out of Hermitage would be a lot less usable. Do you get much sandy material, or is
Yes.
it more muck?
Yes, they get a lot of sand, which is why they were actually trying to sell sand.
Okay.
And in their desilting process. And I was just trying to, you see, they didn't have enough trucks when they started the process. They know they didn't have it, so they said that they would let private companies, provide the trucks to help to move the sand that they'll be putting the machines in to excavate. But you go start charging for it, and then all that now just defeat the purpose.
I agree with you. I think if they gave it away, you'd find plenty hands to take it.
Jamaica don't have nothing like freeness,
Nothing like freeness.
Yeah.
Yeah, they would take it and sell it.
Yeah, they'd take it first and then figure out what to do with it after.
Exactly. Yeah.
Yeah.
All right, thank you. Anyone else? Going once, going twice.
Well, I just have a quick question then, if you don't mind.
Richard, make it quick,
Oh, I say,
please.
Alice, oh, I need to make it quick. But so first of all, Peter, I just want to tell you, thank you so much. That has been a very, very interesting and enlightening presentation for myself. I'm not giving a vote of thanks, but I just wanted to get that out there. I mean, if you're in the military, we tell you thank you for your service. So
Yes, that's how. Yeah, thank you for your service and it done right.
So one of the things, just one of the questions I like to ask, I haven't asked it in a long time, was my wave of magic wand. If you had one wish, you've been in this a long time from both, as you say, as an engineer, as a scientist, looking at water from many different angles. If you had one wish, and I know water is a very political thing, and I know you have to be very delicate in terms of how you may have to choose to be very delicate in terms of how you respond, but I don't really have a sense. Let me speak for myself. I don't really have a sense of. I know the work. I hear the work you do, right? But do we have a sense that we're moving in a particular direction? And I know more can be done and more money can always be spent. But sometimes we focus on the bad when there are good things happening, and the future is not as bad as you think, or maybe worse than you think. I mean, just in a very general way, give us your impression. One, of if there was a magic wand you could wave, what would you want to focus on almost immediately? Or two, just how overall Jamaica has done in managing its water resources
All right, two easy
compared to
questions for me.
places.
Two easy questions for me. One, wish. If I had one wish, I would wish that every single one of our watersheds were returned to their best state. That would allow, that would mean that our runoff would be less. It would mean that the quality of our runoff would be better. We wouldn't have it so muddy, for instance, because you'd have less erosion and all of that. So you could capture more storm water. And it would mean that, so ecologically, it would be a win-win for water resources if all our watersheds were restored. And the second thing now, how we see, with all of what's happening and everything, Jamaica is the leading water resource manager in the Caribbean. There's nobody doing it better than us. In Barbados, there's a training college called the Caribbean Institute of Meteorology and Hydrology. It's based there. It's paid for. It was seed funded by the WMO, the World Meteorological Organization, and they have to have field trips. And this year, like every other year, I am hosting students that are coming over from Barbados to work, to be along with my team, going out to see how we operate in the field, to see all of what we're doing. Because when it comes to best practice, check us. When it comes to how we're doing protection of water, check us. All right. And also we have different scenarios to present that other countries don't have. So for instance, Barbados have no rivers. I mean, they have one little creek that run through their capital town, and it's so important to them that they put a bridge over it and call the whole town Bridgetown. It is so important to them. A little creek, if you see it, it's a little creek. You can jump across.
I'm familiar with it.
Right. So they have no surface water. So when it comes to hydrology, they can't, and at the same time now, they can't go to Guyana or Suriname that are what we call blue countries that are awash with water, fresh water, for the simple reason that, when you have something, as we say in Jamaica, wagga wagga, let's put it this way. When I was a boy and I climb a mango tree on our family property, I only eat the bottom yellow half of the mango, The top part of this, I don't eat it. I climb the tree and I sit down and I eat 4 dozen mango. I bite 4 dozen mango. And each of them only eat a quarter mango because I have it like that. So in that sense, they don't have the whole of the concept of the management. They can get away with not having it because they have so much water. So we're in that, I don't know if it's happy place, but we're in that place where we have the technology, we have the resources, we always short our resources. We have the staffing, we have the people that are trained and so on. And so we are the go-to place in the Caribbean. In Latin America, I'm not going to say that in Latin America we are the number one, but we are certainly in the top 5 in Latin America. And in the whole region, of course, we're in the top 10. We're outstripped by, and when I say region, I mean, as it was said, that I'm the president of the hydrological advisors for Canada, USA, Mexico, all the way down to Colombia and come all the way across to Barbados. All right. So, no, Canada is the number one in our region in terms of water resource management. And I've lost over the year, well, not I have personally, but the Water Resources Authority has lost staff over the years, so many to Canada. But we've stopped. We haven't had anybody migrating from Jamaica to Canada in the last 5, 6 years. None. They're staying home. They're staying here and they're helping to make a difference.
Thank you so much,
Thank you.
Peter. All right, so I'm gonna ask our past president, Allison, to move the vote of thanks. Allison,
Thank you.
over to
Thank you, President Yasmin. Boy, I thought Richard was going to do it because, you know, it started out good and then he said he wasn't. Now, I want to really thank you. Peter, you are a wealth of knowledge. We're so happy you came. I've heard you at our Rotary Club before. I heard you speak at the Rotary Club of Spanish Town, and every time I hear you speak, you come with more information, more knowledge, and you're such a treasure to Jamaica. So I want to say on behalf of Jamaica, thank you for being in Jamaica and staying, and thank you for giving us the good news. We have the Bahamas on here. Big up Bahamas. We have through past President Mark Thompson, his father, a charter member of the Rotary Club of Spanish Town, is listening. So thank you for listening, Mortimer. We have the Portmore president, and he brought a lot of his members, including Michael Terrelong, who you know. So thank you, Portmore, for joining us. Kingston East and Port Royal came out. South Ocean, the Rotary Club of South Ocean, community members. I heard somebody saying they're not Manor Park. Don't matter. We're on Earth. And once you're on Earth, we need to hear about water. So as a Rotary Club of Manor Park members, we're so happy that you could make it, including the ones that are at Champs. Peter, you know, it's Champs. And we have a member who's actually a referee. And we have some of them that are just cheering him. I don't know what they're doing there, but, you know, we will just go along, and they logged in. So you are so good that you held their attention. And I really have to give a big round of applause to everybody who stayed and listened and spent the time with us to hear from you and what I took away. Because, you know, normally I listen, but I don't always hear. When I heard you say it is good to be a scientist, I was glad to hear that. When I heard you say how we have to catch water, I was glad to hear that. I'm from country where we had the copper. For those of you that are from the Bahamas, the copper is the old sugar plantation. It's like a little saucer that we would catch water. So you made it clear. Also, you explained how sea rising. You did it such an easy way because a lot of times we hear these things and we don't quite understand. You made such complex things understandable. And more importantly, we didn't get a doom and gloom. And the silting, I always thought the whole of the river, I heard you with Chris, I always assumed the whole of the river full of silt. You explained why sometimes what we think is bad is actually helpful. So I want everybody to give you a round of applause. I won't clap because I loud, but I want everybody to give you a round of applause. And I also want to thank you for showing us how interdependent we are in the region, in the world. Because even though we're a land of wood and water, what I'm seeing with our 100-year-old dam, if we're not careful, we're going to be in problems. And moving to the Bahamas, moving to Canada, moving all about the place, not going to get us. We're still on Earth. So thank you for an amazing presentation. And I hope that you have a long life so we can keep all that knowledge right here in Jamaica. Back to you, Prezi.
Thank you so much, PP.
And Prezi, I won't comment on the mango because I'm a mango eater myself. So good to know somebody admitting that they climb mango tree and eat.
Okay. Before we wrap up, I just want to mention to the members of Rotary Club of Manor Park, please look in the chat, the club chat, because the secretary's report will be posted there, as well as our Sarge will post in the chat. So once again, without further ado, I am now going to ask our acting VP, Chris Nakash, to move the toast for this meeting.
And please remember, our real VP was on, but gone to go measure.
Right.
I
And
hear
I
there's a world
understand
record
that
made. I heard
it's
there's a
very
world
loud
record.
there.
Yes,
So,
no, I'm telling everybody a world record was made at Champs today that he went to measure.
oh,
All right,
okay.
I'll take all the jobs I can get. It's all right, man. I hear
That's
I'm
right.
getting
Hold on to
overtime.
it tight, Chris.
I hear I'm getting paid overtime because it's after hours.
Okay, over to you, Rotarian Chris.
Okay, well, I would like to thank Peter again, as well. It was very informative. But more importantly, I'd love to raise a toast to Rotary Club and to the Club of New Providence, Nassau. So join me in a toast, please. Thank you very much.
And thank you to acting VP. So what's left of me to say is thank you everyone for coming here, and really, really appreciate, Peter, you taking the time. We know how busy our engineers are in this country, especially at this time. And so we really want to thank you for taking the time to be here with us and to give us the kind of extensive information that you gave us. I certainly learned a lot, and I'm sure our other Rotarians and guests learned a lot too. Thank
It
you
was
so
good.
much, everyone.
It was good. Thanks for the invitation.
Thank you, Peter. And I'm wishing everyone a pleasant and restful night, and looking forward to seeing you at our next monthly speaker meeting. Have a great evening, everyone.
Have a great evening.
You.
Thank you, Peter.
Thanks, Peter. Bye-bye.